Since the dawn of the space age, we've imagined traveling to worlds beyond our solar system. Touching down on eerie landscapes, encountering alien life forms. What was once science fiction is now becoming science fact. Each year, we are finding more and more planets around other stars. Some strange and hostile. A few with the potential to harbor life. What can we learn about the universe and about ourselves? As we scan the galaxy for undiscovered worlds. In the last 2 decades, precision telescopes have allowed us to see into the bright light of distant stars and detect the presence of planets. This is 51 Pegasi, a sun-like star about 50 light-years from Earth. In 1995, from slight variations in its light, astronomers discovered a planet orbiting around it. For the first time in human history, we knew for sure that ours is not the only solar system. The planet they found is huge, more than 100 times the size of Earth. Yet it orbits astonishingly close to its parent star. Its atmosphere is a scorching 1,300 degrees Celsius. Whipping around its star every 4 Earth days, this exoplanet defied everything we thought we knew about solar systems. Our solar system began to take shape around 4.5 billion years ago. In a giant cloud of dust and gas. Over millions of years' time, this cloud collapsed, and the sun was born. The cloud flattened into a spinning disk. Inside it, dust and rock collided, forming the inner planets. Farther from the sun, hydrogen and helium gas collapsed into dense centers, forming the gas giants, Jupiter, Saturn, Uranus, and Neptune. The planet at 51 Pegasi, known as a hot Jupiter, is huddled too close to its parent star to fit this pattern. One theory suggests that it formed far out in the solar nebula, but gradually migrated inward. We have much yet to learn about worlds like this, but with each new one we discover, we move a step closer to understanding planetary systems. Astronomers found this planet by searching for clues hidden in the light of its parent star. The planet exerts a gravitational pull, causing the star to wobble slightly. At our telescopes, the star's light passes through a spectrograph, an instrument that breaks the light up into component colors like a prism. The result is a spectrum that shows patterns of lines characteristic to the star. As the star wobbles, these lines shift back and forth, toward blue as the star comes closer, and toward red as the star moves away. Today's instruments are so sensitive that they can measure differences in a star's speed as small as 1 meter per second, the speed of a person strolling down the street. Each wobble represents a complete orbit by the planet around the star. Based on what they know about gravity, astronomers can use this information to estimate the planet's mass and its distance from the star. That's not the only way to detect these far-off worlds. Take the star HD 209458. Astronomers had already found a hot Jupiter with the wobble method. In 1999, this exoplanet was observed passing in front of its parent star in an event called a transit. Astronomers noticed that the star's light dipped slightly, but regularly, every 3.5 days. This dip in its light was tiny, only 1%. But it meant that a planet was there, making one orbit every 3.5 Earth days. Since larger planets block more starlight, astronomers now had a direct way to measure the exoplanet's size. The planet HD 209458b turns out to be less massive than Jupiter, but it's about 30% larger. It is less dense, or puffier, than any planet in our solar system. That discovery led to new techniques for studying an exoplanet's atmosphere. When the light from the star passes through the atmosphere of the planet, The planet's atmosphere imprints upon that light a signature of whatever atoms and molecules are present. In this case, instruments aboard the Hubble and Spitzer space telescopes detected sodium, hydrogen, methane, water vapor, and possibly carbon dioxide. A collection of molecules that elsewhere might be associated with the presence of life. Using transits, we have tools that in theory could detect the signatures of life on a rocky Earth-like world. From what we know, it takes a particular set of chemical building blocks, including molecules containing carbon. Add in a source of energy like a star and liquid water. Around each star is a so-called habitable zone, in which planets are bathed in just the right amount of solar energy for liquid water to flow. Where can we look to find planets with solid surfaces and temperatures that allow liquid water to flow? With literally billions of stars in our Milky Way to choose from, the possibilities may seem endless. But they aren't. Supergiants are the hottest, most massive stars. They're far too unstable and short-lived, and life probably wouldn't have enough time to develop on a planet that orbits it. They are known to explode in supernovas that would obliterate a planet. We can also rule out most double or triple star systems, which make up more than half of the galaxy's stars. With two stars tugging on a single planet, its orbit would probably not be stable enough for life to develop. And the combined light from two or more stars makes these planets even harder to find. What about red dwarfs, the most plentiful stars in our galaxy? They are smaller and cooler than our Sun, but don't emit very much light or heat. Still, they live far longer than the Sun. A red dwarf solar system could survive and evolve over billions of years' time. In the year 2009, astronomers made their first discovery of a rocky exoplanet orbiting a red dwarf star. Called Corot 7. The world goes around its sun in just 20 Earth hours. With surface temperatures at around 2,000 degrees Celsius, this extreme world is probably lined with molten rock. Massive rocky exoplanets like Corot 7b, known as super-Earths, are some of the strangest, most exotic worlds yet detected. Calling it a super-Earth doesn't mean it bears much resemblance to our planet. Most detected so far are simply too close to their central star and too hot for life to survive. There is one newly discovered solar system that may come close. The red dwarf star Gliese 581 is relatively close to Earth, at 20 light-years away. A team of French and Swiss astronomers had been studying its light from a telescope in the mountains of Chile. They noticed a slight jitter, the gravitational tugging of planets. They first deduced the presence of Gliese 581b, a planet with 16 times the mass of Earth. At a distance from its central star of only 6 million kilometers, it's bound to be very hot. Then came Planet C, 1.5 times the size of Earth, with an orbit of 11 million kilometers. Its position just inside the life zone means it's probably too hot. Then there's Planet D, 7 times the mass of Earth at 33 million kilometers from its sun. At the outer edge of the star's habitable zone, it receives only 30% of the light that Earth gets from our sun. Imagine a much larger version of Mars. A planet with a thin atmosphere, no liquid water on the surface, and temperatures that average around minus 59 degrees Celsius. Some astronomers suspect that Planet D is an icy world that migrated in from the outer solar system. On the other hand, what if Planet D possessed some of the attributes of our planet? Geological activity that produced an atmosphere, a moon to stabilize its orbit, and a robust magnetic field to shelter it from solar winds. In the future, as our instruments become more and more sensitive, astronomers will look for signs that it has an atmosphere, and within it, chemical compounds that might be associated with life: methane, carbon dioxide, water vapor. It's not out of the question that we, or a robotic emissary, may one day be able to visit and get a closer look. It's possible that Earth-sized planets, maybe even habitable ones, are commonplace in our galaxy. Given the immense distances and the brightness of their parent stars, the trick is finding them. Until recently, our technology and methods were best suited to detecting massive planets. But that's changing. Launched in 2009, the Kepler Space Telescope was designed to look specifically for Earth-sized planets in the habitable zones of their parent stars. Kepler measures light from 100,000 stars like the Sun. watching for minuscule dips in starlight, the telltale sign of an exoplanet transit. The mission has already discovered an array of giant planets with orbits lasting days or weeks. Astronomers will be combing their data in the years to come for signs of Earth-sized worlds with orbits of a year or more. As astronomers continue to comb their data, they are finding a remarkable diversity of solar systems. Kepler-11, at 2,000 light-years from Earth, has 6 planets, all larger than Earth, packed into orbits smaller than that of Venus. Kepler-20 has 5 planets, 2 about the size of Earth, but all within the orbit of our Mercury. Then there's Kepler-47, a double star system with 2 planets discovered so far. The innermost planet, the smallest detected by the transit method, is 3 times the size of Earth, but it's so close in that its year is 50 Earth days. Farther out, with an orbit of 303 days, planet C is in the life zone of its star. Unfortunately, it's a gas giant a little larger than Neptune. We continue to ask, are there worlds like ours somewhere out there? We now have the technological capability, the telescopes and the computers that will begin to help us answer that question. Whether we find that Earth-like planets are commonplace or rare, there is one thing we know with certainty. Our world is but one tiny grain on the beach of a cosmic sea. Looking in any direction, the universe goes on and on for incomprehensible distances. So far, billions of years have whispered by this small corner of the galaxy. Billions of years will transpire after we all are gone. Our moment of life is like a breath of air. As we look up into the night sky, we wonder what new worlds await our discovery. And what light will they shed on the origin and evolution of our own Earth?